so now I'm going to talk about the independent group t-test. So this independent group t-test is designed to compare population means of the same variable between two independent groups. So we have the mu1 and mu2 similar to the paired group t-test, but their meanings are different. So this mu1 is the population mean from the first group, the mu2 and the population mean from the second group. So these two groups have the different populations. So if we want to compare the mean writing score between a group of female students and a group of male students, they are selected from the larger population of subjects, so they are independent. So and here's our assumptions. So data should be from normal distribution or sample size is large, and two groups must be independent. So if, for example, if these two groups are, say, twins, they are not independent of each other, so we can apply two-sample t-test in that case, two-sample independent t-test in that case, and the observation should be also independent of each other. So there are two cases in the independent group t-test. So variance of two groups are equal, and the variance of two groups are unequal. So we have population variances on each group, and then if they may be equal or unequal. So in each case we have a different statistics. So if they are equal, then we pull the sample variance between first group and second group. So we compute the pooled standard deviation, so which is the square root of the pooled sample variance, because we think that their population variance are equal. So we pull together their sample variance and then the derived one pooled sample standard deviation for them, and then we multiply 1 divided by n1 plus 1 divided by n2 and take a square root and multiply them. Multiply into the pooled sample standard deviation. And here the degrees of freedom is n1 minus n1 plus n2 minus 2. So that's this formula is if the null hypothesis is true, then it has a t-distribution with degrees of freedom n1 plus n2 minus 2. And then if the variance of two groups are unequal, then you compute the variance on each group, so which is the square root of S1 square, which is the sample variance of first group, divided by n1, sample size of the first group, plus S2 square, sample variance of the second group, divided by n2, sample size of the second group, and then take a square root of that. And then this t-statistic is this t-statistic does not have the exact t-distribution, but we have the approximation. So this t-statistic has approximately t-distribution with this degrees of freedom, which is complicated formula. So this is called Welch-Satterwhite equation. By default, the SAS will provide the result of both cases above the test for the equal variance of two groups. So let's look at the independent group t-test. You put a class statement in the gender, and then so variable right, which means that we do an independent t-test, two-sample independent t-test for right score and then different gender. And then you can see that this result. So if you look at this result, there are the 4 parts. The first part is the summary statistic. So it has a mean for each gender, standard deviation for each gender, and standard error for each gender, minimum and maximum. And then so pooled means that we treat the sample the population variance is equal. And so we have the Satterwhite, which means that we treat the population variance are different. So here, and then we have the second part, mean. So 95% comes to the limit mean and standard mean for mean and for standard deviation. And also we have differences for proved for limits for each mean and standard deviation, and satellite for the mean. And then we need to concentrate on the third part on here and the fourth part on here. So before looking at third part, we have to look at the fourth one. So equality of variances means that so for this equality of variances, I didn't say right down here, so we use the F-test. So it has so F-test has a 2 degrees of freedom. So and this equality of variance has the ratio of this, using the ratio of the two sample variances. So sample variance, the degrees of freedom for numerator is the n minus the 91 minus 1, which is 90, and then degrees of freedom for denominator, which is the is the n, this sample size on the second group minus 1, which is the 108. So an F value is 1.61. And then here we need to look at this p value, which is probability. So the equality of variance, so the null hypothesis is that the two variances are equal. And alternative hypothesis is that the two variances are not equal. So here we have the unequal variances on here. So which means that we reject the null hypothesis, which means that we have evidence that the two population variances are different. So we need to go to the satellite method. So we treat the variance as unequal case, and then we have to look at this degrees of freedom, which is 169.71, and then t value is the minus 3.66, and so which is the less than 0.005, which is the p-value is 0.0003. So we reject the null hypothesis that two means are equal. So we conclude that the means of writing score between two groups are significantly different. The male students are significantly better than female students on writing. So you can, before look at t-test, you can produce a summary statistic and plus the box plot. So this box plot helps to look at the difference. And then by looking at graphically, you can do the actual test. So here, and then another thing, important thing is that first need to look at this equality of variance. You need to first to test for the equality of variance so that you decide which test we are going to use. So in this case, we have p-value less than 0.5 for the equality of variances, which means that we have evidence that the two population variances are different. So we have to choose the satellite method with unequal variances case. So which p-value 0.003. And then if you do not have the assumptions for t-test, then we can use a non-parameter t-test to compare two groups. So this Wilcoxon rank sum test is the popular one for alternative of the t-test. And this is very useful when the sample size is small and the data is not normally distributed. So the idea of this test is that if we want to compare mean of two groups, and then we order all the observations. So if by ascending order, so 1.3, 3.3, 3.4, 4.9, 10.3, and then we make a rank for this five observations. So for group A, so we have the rank 1 and rank 3. Then we calculate the normal ranks for group A, which is the 4. And then if we have the smaller rank in group A, we expect that the values of group A be lower hence the smaller sum of the ranks than group B, which means that we have the for the smaller mean than the group B on for another group on here. So by calculating ranks on this testing, so we can decide. I mean, we can use the sum of ranks as a test statistic, and then do the test for determining whether they have different means, population means, or smaller means or bigger means that. So we want to use a Wilcoxon rank sum test to compare the mean writing score between group of female and group of male students. And then we can see that so SAS code is we use a proc and part1 way, and the class gender and the variable right, and then put the Wilcoxon option is it tells the SAS to use the Wilcoxon rank sum test. And the SAS output is that, so we have the sum of scores and the expected scores under null hypothesis and standard deviation under the null hypothesis of the scores. And then we have mean score. So we have calculated rank sum, and then the sum of ranks, and then we use mean score, and then calculate the statistic, which is the 7,792. And then this two sample test, we have the test, the p-value is the less than 0.05. So we conclude that the this test statistic is very slow, even the approximation or the test statistic for Z is very slow. We can determine that the male students are significantly better than female students on writing. Or just simply say mean of writing score between two groups is significantly different because the p-value is less than 0.05. Okay, so let me stop here, then I will talk about the next topic in the next video.